Welcome back to another video. So in last video we talked about how Uber scales to handle massive load of 40 million reads per second. If you haven't watched that yet, I highly recommend you to check that out first. It gives you full context behind Uber caching architecture, because this video is a direct follow up to that. And today we are going to go a little deeper. uh, Okay, so it's not just about a scale, it is about consistency. And Uber serves more than 150 million reads per second. That's massive. But the real challenge is not about scaling, it's about maintaining consistency. So, because once you introduce caching, you risk serving stale data. So, in this video, we will understand how Uber solves hardest problem of the system design called cache invalidation. So, let's start with the architecture first. Uber uses a system called CacheFront on top of Dock Store. Dock Store is a database built top on MySQL, and there are mainly four components. First is query engine, which is stateless. Second is Redis, which is cache layer. Third is storage engine, which is the database, and the Flux, change data capture system (CDC) system. So the idea is simple: serve reads from cache for speed and rely on database for the correctness. Now here's the problem: cache improves performance, but it introduces inconsistencies. Why? Because cache invalidation is asynchronous, and TTL delay updates and failure can happen. So system might return stale data or even incorrect results. And there are few common type of inconsistency. First one is read after write inconsistency. So if you update something but still read old value. Second is read after insert issues, especially with the negative caching. So user might see outdated data or think something doesn't exist when it actually does. So let's understand why this happen, and what are the root cause. So multiple worker might race up to update the cache, and CDC pipeline can have delays. Redis node can fail, replica might lag. So all of these can lead to this cache and data can go out of sync. Now you might think TTL can solve this, but it doesn't fully. uh, TTL only limits how long data stays, but it doesn't guarantee the freshness. If invalidation fails, still data can stay for the entire TTL duration, and in worst case, very old data keep getting served again and again. So, what did Uber do? First, they improved how updates are tracked. They introduced monotonic timestamp, and they use soft delete, also called tombstone, and they tracked exactly which rows are updated per transactions. So now they have know precisely what has changed and what need to be invalidated. And next biggest improvement, they moved cache invalidation into the right path. Now flow looks like this: write to DB, database returns which rows are affected, cache is invalidated, so no waiting for asynchronous system. And this significantly reduces the inconsistency. But they didn't stop here. They combined multiple strategies, like TTL expiration, CDC based async updates, right path invalidation, and this hybrid approach gives them the best combination of latency and consistency. To make thing even better, they build a system called Cache Inspector. So this is a observability platform which basically compare database value with cached value and measure the staleness. So it tracks stale entries, mismatch rates, and gives real visibility into how system is performing, and the results are impressive. So over 150 million reads per second, with the more than 99.9% cache rate hit. So with this, Uber achieved both scale and a strong consistency, which is not easy. So what are the key takeaways? So cache invalidation is hard, but it can be solved. Don't rely on TTL, and track data that changes. Uber uses hybrid strategies and invested in observability. So that was it. I think if you haven't watched the previous video yet, make sure you check that out, and it will give you a full picture. I'll see you in the next one.